In this video, we will talk about hashing. Hashing is a technique to improve the read or lookup performance. Now, hashing is important because without understanding the concept of hashing, we cannot fully understand the inner working of HashSet or HashMap. Before we understand why hashing is required, let's take a step back. Suppose we have this array of 1000 elements. How do we add elements to this array? When we are adding an element to the array, we always add it to the next available index, which is in the increment order. So the first item will go to the 0 index, then next item go to the first index, then second index, then third index, and similarly the last index. So that's how we add elements to the array. How do we get the elements back? There are two ways. If we know the index, then we can simply go to that index and fetch the value, which is fast. But if we don't know the index, then there is this problem. Because now we have to scan the array, now we have to search the element that we are looking for. Alright. If this array is not sorted, then it will be a linear search. If this array is sorted, then we can use, for example, binary search. Scanning is a slow process. And hashing improves this process, and hashing solves this problem. Let's see how. So think about it. Let's say we have an array, okay, and the same array that we saw before, 0, 1, 2 index, third index, and similarly the last index, it could be, let's say the size is s, so the last index will be s minus 1. Okay, and then we have items that we want to store and that we want to fetch, and this is the set of items. So there are I1, I2, I3 and IK. There are k items that we want to add to an array and then we want to fetch them. All right. Now consider we have something that can give us the index quickly. So idea is when we are adding an element to this array, we pass that item to something, and this box will return an integer value, and that integer value will represent the index of the array. So let's say if I want to put I1, then I will pass that I1 to this box, and let's say it returns an integer 0. So I know that I have to put this value to index 0, that is I1. Now next we have to store I2. So what I'll do, we will pass I2 to the same box, and this box will return again an integer value, that is the index. So let's say in this case for I2 it returns the index 3. So I know that I2 will be stored at index 3. Alright. In the same way, when we are finding an element, when we want to fetch the element, we pass the same element again to the same box. So in order to fetch I1 back, what I will do, I will pass I1 again to the same box, and this time also it will return me the same integer. For I1 the index was 0 or the value was 0. So again I will get the same value, which is 0. So I can quickly go to index 0 and there I1 is stored, so I can quickly read the I1. Similarly, if I have to read I2, then I will pass I2 back to the box and it will again give me the same value, which was 3. So I can quickly go to index 3 to read I2. You get the idea. So we are passing the keys to a box, and this box will return me an integer, and that integer value is basically the index of the array. So we can quickly go to that index and we can store the value and we can fetch the value. The benefit is that we don't need to scan the arrays. All right. Now this whole process is called hashing. This whole activity is called hashing. Okay. The box that accepts an item and returns an integer value, this box is called hash function. Hash function is basically a hashing algorithm, a code implementation that we write which accepts an item, and based on some logic it always returns a consistent integer value for a certain item. Okay, the integer values that are returned by this box are called hash values. Okay, so when we pass an item I to a hash function, it returns a hash value, and that hash value is basically an index, and that index represents a location in the underlying array. So that's how hashing works. Okay, now important point about hash function, it must be deterministic and consistent. What it means is that if we are passing the same item to this hash function, it should always return me the same integer index. Alright, so if I am passing I1 multiple times to the same hash function, then for a single execution, I should always get the same value. Otherwise, what would happen? So let's say if I'm storing I1 and I passed I1 to the hash function and I got the index 0. So I stored the I1 at index 0. Now in order to read I1, I will pass the item back to the hash function. But this time, if it is not deterministic and not consistent, it could return me another index, let's say 2. So I would go to the index 2, but there is no I1 stored. So for a single item, for a single key, the hash function should always return me the same index value or the same integer value so that I can store and fetch the items from the same location. Okay. Now let's say we have the set of keys or set of items, key items, the same set that we were talking about, I1, I2, I3 to IK. Then we have this hash function, the box, that will accept the items and it will return an integer value, basically the index. Then we have this array of size k. So 0 index, first index, second index, and k minus 1. Okay, let's name it size m minus 1 because k is the size of keys. Now consider the scenario when k is greater than m. What k greater than m represents is that the set of keys will always be greater than the size of the array. So in this case, we may have 1000 keys, but the size of the array may well just be 50, for example. That means the array can only store 50 elements, but we have 1000 elements. So what will happen? Let's say we passed an item to the hash function and it returned me an integer value 1. So that item was stored at index 1 here. Okay, then I passed another item and it returned me an index, let's say 3. So that item will be stored at item 3 and it goes on. But because there are 1000 keys and the size of the array is 50, so there will always be another value. For that value, the hash function will return me the same index that was returned before. So let's say there is an item I10 and I passed this item to the same hash function, and this time this hash function returned me an index 1. So we go to the index 1, but we see there is already an item at index 1. So how do we add another value to the same index? This is called hash collision. It means for multiple keys, when we get the same index value or the same integer value from the hash function, then this condition is called hash collision. How do we solve the hash collision? Well, there are different ways to do that. One of them is chaining. Okay. Another one is called open addressing. What it means is that given this array, let's say there was an item at index 1, and for another item the hash function returned me the same index. Then to solve the collision problem, what chaining says that you should use another data structure to store the items at the same index. So instead of saving the item directly at index 1, what we do, we use a linked list. For example, it could be singly or doubly linked list. It depends on the implementation. Rather than saving the element directly, what we do, we store the linked list. So if there is a collision, the item will simply be added to the linked list. And in order to get the element back, first we pass the item to the hash function. We get the index, so we go to the index 1. Then to get the item, we scan this linked list. Okay, so that's how we solve the collisions using chaining. What open addressing says that given the array, if at index k you have an item already and there is a collision, so you need to find the next available slot. How do you do that? There are different ways in open addressing. So to find the next available slot, what you can do, you can check k plus 1. That is the next available index. If this is free, add the element here. If this is also busy, then just check k plus 2. And you can use different mechanisms in the same way. Maybe you can try some other formula to find the next available index, possibly the square of indexes. So if there is a collision at index k, then I can check another index using k square. So these are all ways to solve the hashing collision using open addressing. All right. In chaining, we use another data structure, linked list mainly, and all the items for which collision occurs, we simply add that item to the linked list. In order to read the item, we go to the index and then we scan the linked list. In open addressing, we find the next available slot. So this is hash collision, and how do we solve them?